Hey there, this is Math 7, Unit 3, Lesson 10 on distinguishing circumference and area. So trying to be able to tell the difference between whether we want to take a measurement around something or find out a measurement of the space within something, right? That's our circumference and that's our area. So we're going to be looking at some different problems today to decide which one would we use. Well, and we're going to look at some differences between circumference and area there. In your first activity, it was called filling the plate, and it said about how many cheese puffs can fit on the plate in a single layer, and be prepared to explain your reasoning. This is a great little question here, a lot of fun if you had some real cheese puffs, so experiment with it and see what happens. But let's take for example that a cheese puff here in the middle is about this size. If I was to replicate that and say let's just draw some more cheese puffs, something like this, around the same size, I would find that in my case here, I'm roughly about 7 cheese puffs long, is about how many cheese puffs from the center to the edge. Now we're not measuring here with inches or centimeters, but we're measuring with CP, cheese puffs. So in this case here, the plate has about a radius of about 7 cheese puffs, is how that would work. Again, I could draw this up that way and that way, but I have in a sense a value or a unit I could use for my plate. Now in terms of covering the plate, because we're going to cover it, we're talking about filling in the space. When we're filling in a space, we have to decide, is that talking about circumference or is that talking about an area? And when we're covering a space, we should know, or at least have an idea, that we're talking about the area. How much space are we filling up here with cheese puffs? Okay, so our formula for the area of any shape is going to be pi r squared. Now in this case here, because we are estimating and we're asked about how many, we can't do it for real, I could take a value like pi and say that's about 3. We know it's a little more than 3. And I can use my radius, which I said here was about 7 cheese puffs, and 7 cheese puffs squared. And I can look at this and say, okay, 3 times 7 squared. Well, 7 squared is about 49 times 3. 49 is really about 50, so I'm just going to do some rounding here, okay? So 3 times 50, just rounding that up there. Again, we're estimating for pi at 3. We're rounding that up there, so it's not precise. That's okay. We could say we might be able to get about 150 cheese puffs on that plate if we were excuse me, if we were to do this activity for real. Okay, so kind of fun. If I was to answer this in terms of pi, I might say I would have 50 pi cheese puffs, right? Using my 50 there to go there. Again, another thing we learned from one of our previous lessons. All right. One of the next things you did in class is your teacher gave you some different cards with some questions on them. Okay? And what you were supposed to do was to sort the cards into 2 groups based upon whether you would use a circumference or an area of a circle to answer the question. So let's take a look at some of these questions. In question card 1, it says, how much fabric is needed for a round tablecloth? Now if you think about a table is going to be round and you have the table legs, right? If I'm going to put a cloth over that, it's going to cover that. And whenever we're covering something, we're probably dealing with the area. And that's probably what I would say for that first one. Let's go with area. For the next one, it says here, all right, how much green space is there inside a traffic roundabout? So that's like if you have a street, right, and it comes up and you got a traffic circle and it goes like this and like this and it goes there and there and there and there and traffic comes in and out and it goes around. And if we want to find out the green space inside of that, well, that space inside, the amount of green space that's covered, would again be an idea or something like an area thing. It's that space inside that helps us know that it's going to be that. All right. That's our area. There's getting a little bit too much glare there. So an area one there. How many square inches of cheese fit on a slice of pizza? So if I have a slice of pizza, all right, and I have cheese all over it, again, I'm talking about covering something, so I would say that that would also be an area type of problem there, right? And then looking at the next one here, We have how much room is there to spread frosting on a cookie. So again, there's my cookie, and because I'm going to cover that up with frosting, that becomes another area type of question. So every time we can cover something, we seem to be doing an area type of problem, right? These next ones here are going to be ones probably more about circumference. How fast do you go when riding on a Ferris wheel? So a Ferris wheel, while it looks like this, like so, to determine how fast it's going, we're going to need to go figure out how far around and how fast around this shape is moving. So in this case here, we would say that our Ferris wheel is going to be probably a circumference problem because we're going to be going around an object to solve that. How many times must a horse go around a horse walker to walk 1 mile? So it's like you have a little horse walker here, and you have your horse hanging out. All right, here's your horse. Lovely horse there, I know. And it's going to walk around, so because we're going around, we would call that the circumference. All right, that's the idea there. How many feet are traveled by a person riding once around a merry-go-round? So again, I have a circular object here, and the person is on the merry-go-round, and they are going around the merry-go-round. And when we go around an object, again, we're talking about circumference. And finally, one last one. How far does a unicycle move when the wheel makes 5 full rotations? So if you had a unicycle, right, there's my unicycle. If this wheel is making 5 rotations, whatever that might be, we're still talking about the circumference of that wheel moving around 5 times to measure the length. I would need to know the circumference to figure that out there. So these are all examples of different things you would use a circumference for or area for, okay? You might have done some estimation of the circle on your card, and your teacher probably gave you some links you might have used there and answer some real questions. So moving on to the next thing, let's go to activity number 4. It says analyzing circle claims. So here are 2 students' answers for each question. Do you agree with either of them? Explain or show your reasoning. So let's see what they said. The first thing was, how many feet are traveled by a person riding once around the merry-go-round? So here we have a girl, and she's going to go around the merry-go-round 1 time around it. Claire says the radius of the merry-go-round is 4 feet. Okay, so here's our radius. It's 4 feet like that. So the distance around the edge is about 8 pi. Okay, let's see if that's true. To find the distance around, we would say that its circumference equals 2 pi r. Okay, and we're going to use r because we know that we have a radius of about 4 feet. That's our radius there. So because our radius is 4, we would do 2 pi times 4. 4 times 2 is 8, and we keep pi like that is. And so she says the distance around is 8 pi. Would we agree with that or disagree with that? Well, if we thought it was 8 pi and we proved it to be 8 pi, we would probably agree with what she's saying and say, that makes sense to me. Let's go with that. Andre says the diameter of the merry-go-round is about 4 feet. Okay. Well, let's see here. Here's the merry-go-round, and he says that the diameter is 4 feet. 4 feet. So the distance around the edge is about 4 pi feet. Well, the circumference of a merry-go-round can also be pi times d. If his measurements are correct, we would say pi times 4, which is rewritten as 4 pi. That does match his estimate there of 4 pi. The question here is that while you can say that that might be right, the question is it a good representation of the real situation here? And this is where we have to think about it. The numbers do seem to line up in both of these problems, but are they realistic numbers on a merry-go-round? If a merry-go-round had a diameter of 4 feet, this little girl right here is probably 4 feet long already. That would mean that if she was to be like across the middle of the whole thing, her feet would go to the edge and her head would be at the other edge, and she's the same length as that merry-go-round. That's a pretty small merry-go-round, if we had to say that. Not very large. This girl looks like more like the radius might be 4 feet on that one, as opposed to the whole thing being 4 feet. Hard to tell. Again, it's just a picture there. So for this problem here, we'd probably say we agree with Claire, and we probably would say we disagree with Andre because the idea of a diameter being 4 feet is probably a little too small to be a real measurement of that merry-go-round. Again, this is just us estimating, and again, all you're doing is explaining or showing your reasoning. So you have to decide what's right, what's wrong. The numbers look right, but do you agree or disagree? On number 2, similar idea here. How much room is there to spread frosting on a cookie? Claire says the radius of the cookie is about 3 centimeters. So we have a cookie, and we have a centimeter, and we say that the radius is 3 centimeters. So the space for the frosting is 6 pi centimeters squared. So we're talking about covering something, so we're looking at the area, right? Before was the circumference. So since we're covering it, we're going to look at the area. And the area is pi r squared. Now if the radius is 3, then we would do pi times 3 squared. 3 squared is 9, and we would have 9 pi centimeters squared. Well, that's what we would have if this was a proper measurement, and she said 6. So far, we're going to disagree with her solution there. We're going to disagree with that one. Okay? Now, how did she get 6 pi? She might have got 6 pi by doing 2 pi r, perhaps is how you end up with a 6, but that centimeter square says you're supposed to be doing some sort of a multiplication there with the radius, so something went wrong in her work there, for sure. So we're going to disagree with her, but we're not sure why she made a mistake, whether she just used the wrong formula or if she did something wrong in a multiplication, but it's definitely not quite right. Andre says the diameter of a cookie is about 3 inches. So we have a cookie here where the diameter is about 3 inches, which would make my radius 1.5 inches. So the space of the frosting is 2.25 pi inches squared. If that was the case, we would say pi r squared, and pi again is, we're going to leave it in terms of pi, so we would do 1.5, the length of the radius, 1.5 squared times pi. And 1.5 times 1.5, and we work that out there, 1.5 times 1.5 is equal to 2.25. So 2.25 pi. That does seem to match that right there. And again, it's inches squared, so we're okay with our units there. And realistically, can you have a cookie that is going to be 3 inches in diameter? Yep, it's a pretty big cookie, so you certainly could, but that would work. And we can have a 3-inch cookie, and no problem there. We would say, yeah, we're probably going to agree with Andre on that question right there. And the last one that you looked at today in Activity 4 is how far does a unicycle move when the wheel makes 5 full rotations? Okay, so we're talking about the unicycle. The unicycle, to make the rotation, we're talking about the distance around the outside. That distance is the circumference, and we're going to do the circumference 5 times in order to make this work. Okay, it's the distance around, and circumference is 5 times. Claire says the diameter of the unicycle wheel is 0.5 meters. Okay, well, maybe 0.5 meters. So 0.5 meters here, and in 5 rotations it's going to go 5 over 2 pi meters squared. Well, if that's right, then the circumference is going to be equal to, the diameter, which she said was 0.5 meters, times pi, and we're going to do that 5 times. So in this case here, 5 times 0.5 is going to be equal to 2.5 pi. 2.5 pi. Well, that's all right. If I was to write this as a fraction, okay, I could think of it this way. I'm going to rewrite this whole problem over here. 1.5 can be written as a half, and a pi, and a 5. So this makes a little more sense. It might help you out. 5 times 1 over 2 is 5 over 2 pi. Now, this is the circumference. So my answer is 2.5 meters or 5 over 2 meters. Those are my 2 answer choices. Now look carefully, attend to some precision here. What's happening with her solution? With her solution, she has 5 over 2 pi meters squared. The thing is that our values here match what we have over here, but what doesn't match are the units that she's using. When she put it in meters square, we use meters square for area. Circumference just stays meters. There's no meter square. That is not the proper notation for circumference. So the problem with her answer is that she put meters squared. If she was to eliminate the meter squared, we would say it'd be okay. But unfortunately, she added that part there. So be careful how you label things. It makes a big difference. Andre says, I agree with Claire's estimate of the diameter, but that means the unicycle will go about 5/4 pi meters. Okay, again, because of what was said before, we said that it's a half meter in diameter, okay, times the meter and go 5. We know it should be 5/2 meters is what it should be. So and pi, sorry about that, 5 pi meters. So the problem with Andre's statement is he has the wrong numbers there. 5/4, something's a little off with his. And it could be that maybe he squared this or something, multiplied that by itself to get 1/2 times a half to get a 4th. Not really sure what he did, but that would be the wrong number. So we'd also end up disagreeing with Andre as well. Okay, let's move on to our lesson summary for the day before we move into our homework section. Essentially what we're saying here is that sometimes we need to find the circumference of a circle, and sometimes you need to find the area. These are some examples of quantities related to the circumference of a circle. So the length of a circular path would be a circumference idea. The distance a wheel travels around a rotation is a circumference problem. The length of a piece of rope coiled in a circle is a circumference problem, right? Whenever we're finding a distance around an object, that's going to be the circumference. Now here are ones with our area. The amount of land that is cultivated on a circular field. So here's our field, and we're talking about the land that's cultivated in that field. The space inside is the area. The amount of frosting needed to cover the top of a round cake. Again, we're covering, so that's area. And the number of tiles needed to cover a round table. So if we have tiles all over that, again, we're talking about area, because we're covering something up. In both cases, the radius or diameter of the circle is all that is needed to make the calculation. So we always need the radius or diameter in order to make the calculation, and we're going to either use the formula for circumference, which is 2 pi r, or the formula for area, which is pi r squared. Make sure you pay attention to your units. This will end up with units squared, and this will just be whatever the unit is, centimeters, meters, for those things there. Okay, so as you start your homework, just press pause and then come back in a second to see how you did. Alright, for each problem, you need to decide whether you're going to use circumference, I'm going to call that C, or area of the circle is the most useful for finding a solution, and explain your reasoning. I'm not going to do the explaining reasoning. You need to write out your own written explanation for that, okay? So, a car's wheels spin at 1,000 revolutions per minute. The diameter of the wheel is 23 inches. You want to know how fast the car is traveling. So we're talking about a wheel. Here's a wheel, and how fast it's going around. Going around and around, we would call that a circumference, wouldn't we? A circular kitchen table has a diameter of 60 inches, right? 60 inches, no problem. You want to know how much fabric is needed to cover, there's our key word there, the tabletop. So because we're going to cover that there, we would say this would be an area problem. A circular puzzle is 20 inches in diameter. All the pieces are about the same size. You want to know how many pieces there are inside the puzzle. Again, this is in the puzzle, kind of like covering up or being on. We're inside that circular frame. That would be an area question. You want to know how long it takes to walk around a circular pond. So there's the pond, and you're walking around it. We would call that a circumference problem, wouldn't we? Number 2, it says, the city of Paris, France, is completely contained within an almost circular road that goes around the edge. Use the map with its scale to estimate the circumference of Paris and estimate the area of Paris. Alright, So I'm going to do this here with my ruler, but just know your book might be a little different. This happens a bit when I do this, right? So if you've watched enough videos, you know they're a little bit different sometimes. As I measure this, I'm going to look for, first of all, the diameter. Well, first I'm going to look at the scale. When I look down here at my scale, what I notice is that for me, about 1 centimeter is the equivalent to 1 mile. So I'm going to use a centimeter ruler to go across this. And when I go across, just to estimate this out, this is over here, we're at about 8 centimeters is about the diameter of my map of Paris. If the diameter is equal to 8 centimeters, that would make my radius equal to 4 centimeters, okay? So to use these values here, circumference would be equal to pi times the diameter, right? And pi is 3.14 times the diameter, which is 8 in this case, right? And so 3.14 times 8 is going to give me 25.12 miles is going to be the circumference there. Now that's what I have when I'm estimating for 8. I will tell you, and your teacher will help you out with this too, again, measure yours, don't just measure mine. I believe that your distance here might be about 6 centimeters. So measure yours and see. I don't have yours with me, so you need to measure yours and see what your diameter is going to be. I don't know. Okay, for the area is going to be pi r squared. And in my case, I said that my r was equal to 4. So we have 4 squared. And 4 squared is 16. If I left it in terms of pi, I could say 16 pi. If I multiply that out, I could do 16 times 3.14 and end up with 50.24 meters or miles squared. Okay? And that becomes my area one there. If again, you use a 6, okay, which might be, yours might be a 6, you're going to plug a 3 into that place because it's 3 squared, and then you can solve that out to see what you come up with there, if it was a diameter of 6, okay? So that's kind of a questionable, I'm not sure what yours says. For number 3, it says we have a diagram of a softball field. We want to find out about how long is the fence around the field. Okay, it's a great question here. And what we see is this field is basically 1/4 of a circle, isn't it? Right? This could continue out here and all the way around to get a whole circle. And so the distance around that fence field there and there and there, we're talking about a little bit of circumference. Okay? So our circumference is going to be 2 pi r. Now I'm choosing 2 pi r because they gave me a radius right here of 250. Right? So I do 2 times pi times 250, but the other thing I want to include is this. This is only going to be 1/4 of the whole thing. I only have that much of the circle. So 1/4 times 2 times pi times 250, there's a whole bunch of a mess there, that's going to equal, let's take a look here we have, right? We have 2 over 4, which is a half, and a half times 250 is 125 pi. Now that's just the length of the curve, 125 pi. I also need to include the length of the fence here and the fence there, or I have a 250 plus a 250. So I would add that in and say I have 500 plus 125 pi. So my 500 comes from the 250 combined, and the 125 pi will be the fence around the entire field. I need to include the infield and the outfield there. To find out how big the outfield is, it's best to find the area of the big thing and subtract this circle on the inside. So my area is going to be pi r squared again. So we have pi times 250 squared, right? But this is all going to be 1/4 of that mess right there, okay? So 250 squared times 250 is going to be 62,500, and I'm going to divide that by 4 to end up with 15,625 pi for the area of the whole shape here. But I want to subtract from that the infield part. Now the infield is also a circle. We have pi r squared. Now my radius here would be half of 110. Half of 110 is 55 squared. So we do 55 times 55, and that gets me 3,025 pi. So to find out the area of just the outfield, I'll take this big chunk and subtract the little chunk and end up with a new solution, which is going to be 12,600, and we're going to go pi, and these are all going to be feet squared because we're talking about area there. So I take the larger and I subtract from it the little bit. And this isn't perfect. This circle goes a little bit outside and inside, so it's not a perfect circle there, but it gets me pretty close for answering about how long something is. Let's look at number 4. While in math class, Priya and Kieran came up with 2 ways of thinking about the proportional relationship in the table. Both students agree that they can solve the equation 5k equals 1750 to find the constant of proportionality. One guy, Priya, says I can solve it by dividing 1750 by 5. The other one says I can solve it by multiplying 1750 by 1 over 5. Okay, so what value of k would each student get using their own method? What's the value of k that they would get? Well, if you do this, if you do 1750 divided by 5, you end up with 350. If you do 750 multiplied by 1/5, you end up with 350. So no matter which way you do, you end up with the same value of k at 350. So the reason these are related is that 5 and 1/5 are reciprocals, right? When I divide by 5, dividing by 5 and multiplying by 1/5 is doing the same thing. But because 5 and 1/5 are reciprocal, I change the operation around to end up doing the same thing there. Okay? And we saw this a lot when we were changing our k values back and forth to go from one way to the other. Okay? Explain how each student might approach solving the equation 2/3 k equals 50. Well, they each would approach a little differently, right? For Priya, the way that he would approach it there would be by, they would probably divide by 2/3, sorry, yeah. So for Priya, he likes to divide by 750 by 5, so they would divide by 2/3, divide 50 by 2/3, so it would look like this, k equals 50 divided by 2/3. That's probably how he would set it up. For Kieran, would probably multiply by 3/2. Okay, so that k value would be, in this one here, k value would be equal to 50 times 3/2. And that's probably how they would go about solving it based upon what they like to do. Okay, that's it for today's lesson. Hope it helps. See ya.